Now the question that we are looking at is course schedule. It's a classic cycle detection problem. What we have to do is we have to finish all courses if and only if the prerequisite graph has no cycle. So the cleanest approach is our Kahan's algorithm, which is the BFS topological sort. And now how it works is that we start by building an adjacency list where each prerequisite points to the courses that depend on it. And then we track each course's in degree, which means the number of unmet prerequisites. So we start with all courses that have 0 prerequisites and then take them one at a time and decrement the in degree of their dependence. Now, whenever a dependent in degree hits 0, it becomes takeable. So if you manage to take all num courses, so there in that case there will be no cycle, and the answer is true. If some courses never reach in degree 0, that means they're stuck in a cycle, so you just return false. So I will start by going through the code step by step. Now if we look, we start with building a graph. So what this will do is it will create one empty list per course. And then, for example, graph of P will hold all courses that require course P first. And then we have in degree 0 times number of courses, which tracks how many unmet prerequisites each course has. Then over here we are building a graph. So what this is doing is that each pair in prerequisites is course comma prerequisite, meaning to take course you must first take its prerequisite. So we add an edge from prerequisite to course, and that's why we are doing graph prerequisite dot append course, and then we bump the course's prerequisite count by 1. Then over here is we are finding the starting courses. So this one, Q equals to dec, that's the data structure we are using, which is a double-ended queue. What it does is it gathers every course with in degree 0. So courses that you can take right now with no prerequisite. So if this queue starts empty and your number of courses, num courses, is greater than 0, which means every course depends on something, so it already implies a cycle. Now you set your taken to 0, you have your while loop, so until the queue is empty, what you're doing is you're actually taking courses. So you pop left, which removes a course from the front of the queue, and then your taken counter increases by 1, which means it's completed. Then your next step involves unlocking the dependent courses. So for each neighbor over here, which means a course that required the one we just took, we decrement its in degree, so one of its prerequisites is now done. Now if this in degree drops to 0, all its prerequisites are satisfied, so it goes into the queue to be taken later. Then we have this final check, which is when your taken is equal to number of courses. So what we are doing is we are asking, did we manage to take everything? If it's a yes, then the courses form a valid order, so no cycle. And if some courses were never taken, they are unlocked in a circular dependency. For example, A needs B and B needs A. So their in degree never reached 0, and then we return false.